So, hi everyone. Thanks for tuning in to the Render Sponsor Lecture. This year is the first time we're being sponsored by Render. Render is a hosting service, or they provide a hosting service. And we've sort of shifted Web Lab to be using Render. We're very fortunate to have Render as a sponsor this year. And without further ado, I'll pass it on to Sean, who will talk more about Render.
Use this mic or use this. I'll probably just use this. Okay. Hello. 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 Spoilers. So hi, everybody. My name is Sean Moore. I'm an engineer at Render. And here we're going to talk about some of the cool stuff Render does for you, but also how it works behind the scenes. So hopefully you get, some perspective about what it is you're getting when you sign up for Render. So a little bit about me. My name is Sean Moore. I am a product engineer at Render. I've been programming for a while, probably too long, honestly. I've been at Render for 1.5 years, and previous to that, I was at Stripe for 4 years. A couple other random things about me. I love Ludum Dare. So Ludum Dare is a 48-hour game jam where you make a game completely from scratch. And I heard that one of your lectures this week was about like web canvas UI. So here's an example of a game I made for Ludum Dare. I don't know if it shows up very well on the projector, but the idea is you jump around, you try to avoid the sun because you're a vampire. And if you stay on the sun too long, then you explode. So this is a fun, 48-hour game jam, made everything from scratch. Don't read the code though, because my trigonometry definitely goes downhill, like after an all-nighter. But yeah. And then specific to MIT, I did teach an IAP in 2006, which is probably like before some of you were born, which is kind of scary to think about. But yeah, I don't think we'll talk about zapping unicorns with wands of lightning today. Maybe in the Q&A. All right, so Helen did a great job of walking through how to get your code on Render, but I'm going to do the same thing, but maybe explain a little bit about how it works behind the scenes and what's going on that you don't see. So I'm going to start by creating a repo. Oh, sure. Sorry. Share my screen on Zoom. Yep. Okay, I think we're all set up. So I'm using Next.js, which I think a lot of you are probably using. I'm just going to take all the defaults here, install some dependencies. It's complaining about Node. That'll probably be fine. Okay, so it's complaining that my Node version is a little out of date. It's because bear with me. Web development. Now, if I load this up. All right. Now we have a Node app, a Next.js app running on my laptop. So what I'm going to do now is I'm going to commit that. I think already is there. Yep. So I'm going to make a Git repo on GitHub, which I filled out here. Not really interesting, standard stuff here. Make sure that's copied. You can see I did this before. Push that to GitHub. Now my code's on GitHub, and I can use Render now to deploy it. So my dashboard, I can go to a new web service. Yeah, Helen walked through all this, so I'll kind of go quickly here. But what we're doing right now on this page is we're looking at all of the Git repos that are associated with your GitHub accounts. We can see here that the top one here is one I pushed a few seconds ago, called IAP. Now, what Render's doing during this loading screen is looking at the contents of the Git repo and is trying to figure out what you're doing. So for example, it knows that I'm using Node because it saw a package.json file in the Git repo. It looked at, other signals like what's in the package.json file to see, are you using npm or using yarn? And really the intent here is like, just do what I mean, right? Ideally, the only thing I should have to specify is the name of the service. Yeah, we'll do US East. There was a question previously about like what things here could you change? You can change the name, you can change, the root directory, all the environment variables. I'm not sure if you can change the region. You might have to deploy a new service to change the region. But pretty much everything else is up for grabs. And then when you're doing this team project, definitely use a starter, standard, or whatever plan. Don't use free. You have the credits, use them, please. And the reason you don't want to use free is we actually scale down your service to 0 if it hasn't had traffic in a few minutes. And that's just to make it so we can actually sustainably offer free services. But since you have credits, use them. That way your service is up and running all the time. All right, so I'm going to create that. And what that's going to do is now clone the Git repo, which you can see here. It's looking at the most recent commit on the branch I specified, which was master. It's using a more modern version of Node than my laptop. You can change that with an environment variable or like a .node-version file in your repo. And then it's running the build command, which is something I specified on the create service page. This is like a standard JavaScript thing where you install your dependencies and then run the build. And we can see here it installed 360 packages as dependencies. It's complaining that there's no build cache found. That's Next.js saying, hey, it would be a lot faster if you had a build cache, which we'll talk about in a minute. And then a lot of this is, just Next.js telling you what's going on with the build. There's 0 vulnerabilities, which is great because I just installed everything fresh. So hopefully there's no time for that to get stale. We're downloading web fonts, I guess. And then, yeah, we see here that we successfully finished the build, which means your build commands, ran through to completion. And then after you have that build, which is kind of like a Docker image or like a big zip file of files, I guess, we have to upload that somewhere. And we upload that to S3. And then another process will download that image or tarball or whatever, and then run your start command. So your start command is what actually like invokes your service. In here, npm run start is probably the most typical JavaScript start command. If you're using something like Python, that would be whatever, Python 3, ... But we can see here that at the end of it, it says your service is live. So if we click through to this, we should see this is the Next.js Hello World application. So briefly what happened, we cloned the Git repo. I have a slide for this. We cloned the Git repo. We ran your build command to produce a build artifact. And then we ran your start command to actually launch your application. So there's a couple things interesting going on here. For example, how do we know when you update your code to do a redeploy? So I'm going to test that. So I'm going to change the code here. Say hello, MT. Then I'm going to commit that. Now I'm pushing this to GitHub. And what GitHub does now is tell render, hey, this repository has a new commit. You should probably deploy it. And if we go back to our web service and go to the events page, we can see here we have a new deploy started automatically for you with a commit message to sort of show you that this is the right commit. And indeed, if we look at the diff, we can see that is what I committed. We look at the deploy, we'll see a couple things that are a little bit different. The first is that we download a cache. What that means is the previous build we did downloaded a bunch of dependencies, ran a bunch of compilation steps, and like naively, we would just throw that away. And every single time you push or deploy, we'd have to do all that work again. But that's kind of wasteful. Your dependencies don't change every single time you commit. So we can cache your dependencies so that subsequent builds are much faster. And indeed, Next.js is not complaining about a missing build cache because we cache that content as well. We can see here it's 283 megabytes, which is kind of mind-boggling given that it's a hello world, but that's how it goes. And then it looks like everything's deployed, or rather it's finishing up. So yeah, maybe I'll take a beat here. Are there any questions so far? And I guess for the rest of this lecture, like if you do have questions, just raise your hand or shout them out. We have plenty of time to talk about, to go deep on anything, or if you're curious about how something works. But yeah, we can see here my malformed code is live on render. Okay. So there's a bunch of other things render gives you. For example, metrics and logging. So if you're not familiar with metrics and logging, metrics is like this request took this amount of time to service. And it's one of the things you look at if you're saying, are we like successfully providing this service to users? If there's a spike in errors, you probably want to look at that, right? If your application is like fully down, then your users are probably not happy. So you want to fix that. And so metrics is what we kind of use as a bucket term for all of that. We also capture all of your application logs. So if you use console.log or printf or anything like that, we have that in the terminal for you. And if we go back to render, we have this log explorer. And so this is where we're looking at the deploy logs, but it's also where your application logs are. So you can see here, there's a lot of web traffic, a lot of 404s, a lot of 200s. For example, we downloaded this JavaScript, this compiled JavaScript file. And maybe if we're like, oh, there's something wrong with our JavaScript, we can search for .js. Oh, pay no attention to that. That's fine. It's live demos. Yeah, maybe we can filter by, show me all the things that failed. So maybe 404. So we can see all those. And now we can say, oh, this should have worked. I don't know why it didn't work. Now I can go and diagnose what's going on. A couple interesting things about the logs are you might have multiple instances of your application running. For example, if you are serving a lot of traffic, like Facebook or something, you're going to have thousands, or maybe in this, for most services, couple of instances of your application. But we unify all the logs here, so you don't have to go like connect to instance A and then connect to instance B and connect to instance C and download the logs individually. So that's nice. We also recognize that this is not the most powerful tool for analyzing your logs. There's a whole industry of like metrics and log companies that will ingest your logs and metrics and give you things like alerting. So you can actually get paged if your error rate spikes. Or you can kind of get better analytics into, like, given this set of logs, what's actually going on behind the scenes. And so we have a way to like transmit the logs to a third-party service provider. Next, we talked about build caching. Pre-deploy command is interesting. This is what happens if this is a command you can provide, but that runs between your build command and your start command. And you might use this for two things typically. One is a database migration. I know you're all using Mongo, so database migration is not really something you usually do. But the idea there is like if the shape of your data changes, you want to update your database before you start running new code that expects the new code, expects the new shape of data. So for example, if you're running like a commerce site, maybe you're tracking like transactions per individual. And then you want to start actually tracking like the total spend of an individual. You might have a migration that like sums up all the transactions and updates the database with the total spend. And that way your new application doesn't need to do that logic. It can just assume that it's there because your migration was run. Another way that pre-deploy command is useful is like uploading files to a third-party provider or something like that. Basically, anytime you want to do stuff that's like related to your deploy, but not like running in the main service. Teams and projects. So Render lets you organize your application into projects, which lets you group things. You know, if you have a bunch of applications on Render, you know, having just a big list on your dashboard is maybe a little cluttered. So projects will let you organize your services into applications. So you can have your database close to your web service and your cron jobs close to those and all that. And then Teams you're familiar with, because I think most of you are using Teams for this project. But the idea with Teams is you can collaborate on a project together. And behind the scenes, these are basically just identifiers that we use to group things together. There's of course a lot more behind the scenes, but if that's your mental model, it's probably pretty close. Next, we have preview environments, which is a really cool feature. And so with preview environments, you can say, when I push a new PR, a pull request to my application, I want Render to spin up a completely separate application, like a completely separate deployment automatically. And what you can do with that is when you push some code, you can have it code reviewed, but you can also have like the application itself reviewed by your teammates or coworker. And we'll talk a little bit about how that works in a bit. Couple other things Render provides, custom domains. So instead of saying like capbook.onrender.com, you can have capbook.com, which I wouldn't recommend going there. I don't know what's there. But yeah, the way we handle that is you basically set up a CNAME or an A record that points to the Render URL. And then we have manual automatic scaling. This is something I sort of alluded to earlier, but if you have a lot of traffic, maybe one node or one instance is not enough to handle it, right? It's slowing down because you have a lot of requests coming in that you can't service in a timely fashion. So manual automatic scaling let you say, I want to deploy n copies of this application. And each copy then can serve, one over n traffic, which hopefully is enough to sustain, all the users you have. Manual scaling is just what it sounds like. You say, I want this number of nodes. Automatic scaling is a little bit more dynamic. You say, if the CPU or memory is like overloaded, then automatically add an instance or two. And if it's very quiet, you're just wasting resources, then automatically scale down. And so we have users who are like, very much based in business hours. And so they use automatic scaling to say, during the workday, run 10 instances, and then overnight only run one. And they don't have to manually manage that. It just happens automatically based on, the signals that Render has about your CPU and memory. You can also SSH directly into your instances, which is pretty cool. So what does that mean? So in your service page, there's a shell tab. And if you click into that, it's asking me to redeploy my service, but it looks like I didn't have to do that. So this is, a shell in your application. We can see, that my code is here. If you write any files to disk as part of your normal processing, those will be there as well. And then we also give you a command to actually just SSH directly from your real terminal rather than using the web terminal. The SSH thing is actually pretty interesting behind the scenes. You have to configure your public key in your user accounts, but once you do that, it's all open for you. So Render lets you deploy pretty much anything, and you can provide any Docker container to us. But what if your Docker container doesn't have an SSH server? This still works because we do some cool stuff behind the scenes of like, I don't know, deploying an SSH server for you without having you to do it yourself. In the beginning, you might have noticed, actually I can show you real quick. This page, this is when you have no services and it's asking you what you want to create. So these are all the things that Render lets you create. Web services is probably where you'll start. Private service for Mongo. The only difference between a web service and a private service is whether we publish your web service on the open internet, or with private services, it's only available in like a private VPN to other services in your Render account. So we set up that sort of virtual private cloud for you. Background workers let you do things like queues or streaming. Cron jobs let you run commands periodically. So every hour, download the latest data from the stock market or something like that. Postgres is our managed data store offering. And so if you're using SQL, I highly recommend using Postgres. What Render gives you on top of just like a database is things like encryption at rest. So you don't have to worry about your data leaking. Automatic backups and easy recovery of those backups. You just basically get it for free. And then when it comes time to recover a backup, you click a button and it'll create a new database in your Render account with that data for you. And if you know anything about backups, if you're not regularly testing them, do you really even have backups? So it's nice that it's that easy. Redis is sort of an in-memory data store, commonly used for caching and things like that. And then Blueprints is something we'll talk about in a bit. So yeah, I already talked about all of this. So Render is really good at running Postgres and Redis, but as you all know, you can run Mongo, you can run MySQL, but you just have to do a little bit more of the work because it's basically running your own application. And so Render doesn't have as much insight into what's going on. We talked a little bit about static sites, but a static site basically doesn't need a running backend. You don't have like a node server or something running in the backend. It's essentially just a bunch of files on disk. And so Render optimizes for that use case. So when you push a commit to a static site, Render will build your application just like normal. But then instead of deploying to a new instance, it will upload those files to Cloudflare, which is a global CDN. And that's valuable because Cloudflare is really good at serving lots of web traffic very quickly. They have data centers, I don't know, everywhere in the world, basically. So if you have users in New Zealand, they'll have a very fast experience because Cloudflare has a presence in New Zealand, probably. I don't know off the top of my head. Whereas Render, you saw we have 4 regions, Ohio, Oregon, Frankfurt, and Singapore. So if you can deploy your site as a static site, it's probably a good idea. And so I've been talking a lot about like bits and pieces of Render, how you might use this feature and this feature and this feature, but these all work really well together. We designed it that way on purpose. So your front end, what your users load in their browser might be a static site or a PWA/SPA, which is a fancy way of saying like a complicated website. Instead of using a backend server to like, you click a link, sends a request to the server sends the response back. A single page app kind of does all that in JavaScript, so the experience is much nicer for users. And then your backend could be a single monolithic service, which is probably what you'll do for your project. But you could also split up into microservices and things like that. And like we talked about, Render has like a virtual private cloud for your Render account. And so even if you have a service that's like doing some, I don't know, ML or something, you don't have to expose that to users on the internet. It could be set such that only other services in your Render account can use it. And then we also offer blueprints. So as you were setting up your project, you did a bunch of clicking through the Render application. You maybe did new web service. I want to get repository, tell what repository, branch, region, all that. That's great, but it's like a one-off. If you want to deploy a second copy of your application or something, you'd have to go through all those steps again, and hopefully you get it all consistent and correct. Similarly, if you want to change anything, you have to go to the dashboard and make those changes, which no one's going to review, right? I have edit access to my Render account, so I can just change things. So we have this feature called Blueprints, which is pretty cool. which lets you specify your render services and databases and all that in code. And what that looks like is a big YAML file. So YAML looks like this. We can see here that this is setting up a WordPress deployment. So WordPress is like, blogging or, any sort of like database backed web application. So we say we want a web service. Its name is WordPress. There's some stuff here. We want to attach a disk to it, which means, give it some storage that'll last between deploys. And then we specify all these environment variables. We can see here that we are configuring the WordPress DB host to use the host property of the MySQL WordPress private service. What that means is Render will spin up a MySQL for you and then fill in this environment variable for you automatically. So if you know what like a symbolic link is, it's kind of like that, where you specify how you get the environment variable value rather than specifying it in code or the .env file that Helen showed you. We also have a private service here. Here's the repository where it lives. Here are the environment variables that you need, things like that. And so this is code. I can push, I can commit, I can get a code reviewed in a pull request, and Render will automatically take those changes when you merge this to master or main. So that is pretty cool. Here's an example that's a little bit more complicated for a Mastodon instance, which is a social network, sort of federated. You can see here, there's a lot of stuff going on here. But yeah, at the end of the day, it's like a database and web service and a couple other things. I would say for, a few week long project, you're probably fine just using the dashboard, but it's nice that you can kind of grow into this more advanced feature if you need it. One cool thing we do is called zero downtime deploys. So when I was working on this, I ran yarn dev. I made some changes. I killed the server, ran yarn dev again, right? If someone were to try to use my application while it was down, while I was like taking the updates, then they would get an error, right? It would be like, 500 forbidden or some error code. Obviously that's not great. I always get personally very frustrated when like my bank's website stops working all day Saturday. It's like, what year is it? And so Render, we know people don't like that. We know your users don't like that. And so we have a feature called zero downtime deploys. How this works is when you deploy a new version of your code, we will actually keep the old version in place. We will spin up the new instance, wait for it to be healthy, which I'll talk about what that means. And then once it's healthy, we move traffic over to the new instance, and then we tear down the old instance. So at no point is there like a chance for the user to see an error because the server's not there. And so what healthy means is there's kind of a common pattern where your application has a health check endpoint. And what the health check endpoint, like a URL in your server, what that will do is, connect to the database, make sure that the database is working. Maybe it'll, connect to this other application, make sure that that is working. And so you can use this to say, yeah, I think my application's up and running. If the database is down, your health check would fail. If that other application is down, your health check would fail. And so Render's like, okay, something's wrong. Maybe your new code isn't working. Maybe it has a bug, or maybe something went wrong with the deploy. And so it will, in those cases where the new code can't spin up correctly, it will just keep the old instance running. And so when you have a deploy failure, it doesn't necessarily mean that your service is down. It means it's probably just not running the latest version of the code. So that's nice. And yeah, my takeaway for you today is, you could build all these things yourself, right? Like this process of zero downtime deploys, you basically have a load balancer, it's smart about which version it's serving traffic to. But like, do you really want to build that? Maybe you actually want to build like a website for looking at cat photos, right? And so Render tries to take on as much of this undifferentiated work as it can. We know that you don't very few people care deeply about deploy systems. If you do care about it, please let me know and I'll chat with you about joining Render, but most people don't, right? And so we want to take that toil away from you. And so that's really the value proposition that we offer. So thanks everybody for listening. If you want to get in touch, if you have questions, my email address is shawn@render.com, SHAWN@render.com. But yeah, I'm happy to take questions live now if you have any, or go deep on any topic. Yes. Yeah, so the question is, in the shell, which I'll go to, do you have root access? And I think the answer is no. Yeah, so I don't have the password here. So yeah, you do not have root access. But if you need root access for something, I guess like installing packages or something, you probably want to specify that in like a Docker file, ultimately. But yeah, it really depends on what you're trying to do. Any other questions?
Things that you're currently working on? Like, what are things you have upcoming that you want to do to make Render better?
Yeah, there's two that my team are working on. So we have this projects feature, which we're really trying to get you to use because we think it's pretty cool. What projects let you do is organize your application or organize your separate applications into units. Inside of a project, you also have environments. So you have like a production environment, a staging environment, QA environment. And those are just different deployments of your application. It's the same code, same services. We really want to go all in on that. So for example, if you push a commit to GitHub, we want to deploy to staging or QA first, make sure that it's good, and then deploy the same commit to production. That way you can, catch errors before your users see them. We also want to do things like network isolation. And so your production database should not be accessible by your staging services because that could really go wrong. Like you might expect staging is sort of this ephemeral environment you can mess up. But if it's talking to the production database and you delete the production database, it's going to be a bad time. The other thing we're working on is role-based access control. And so in a team of 3 people, everyone having super user access to everything, that's fine. But if you have 100 people company with lawyers and I don't know, all sorts of other people at the companies, you don't necessarily want your lawyer to be able to deploy production. And so being able to control who has what access is important. Yes.
Maybe how that works.
Yeah, so the question is about, more details about auto scaling. So in this service, I can go to the scaling tab and I can manually scale it. I can say I want 49 instances of it. I'm not going to click save because that would spin up 48 more instances, and 7 times $48 is more than I want to spend on this demo. But if you're a large user, you might need that. So maybe we can scale up to 3 or 4. And what that's doing is basically just 3 new deploys on 3 new servers in the cloud. So we'll see in the events tab, instances changed from 1 to 4. And so now what happens is Render will say, oh, there's 4 instances here. I'm going to basically round robin each request coming in to each of those 4 instances. And that way, each instance serves only a quarter of the traffic that the whole application serves. And then auto scaling is even cooler. Ooh, there's a warning interstitial here. You can say, I want to run between 1 and 22 instances. If the CPU is above 60%, then scale up, because that implies that your servers are having trouble keeping up. The same with memory. You can turn that off if you don't care about memory. But yeah, and then Render will start automatically watching your CPUs and scale up and down appropriately. As far as our actual load balancer goes, we have an in-house tool we call, and what Proxy's job is, if you go to this website, the onrender.com domain points to like, I don't know, a dozen specific IP addresses. And so we have a dozen servers that are serving all the traffic of all render users, basically. So the job of the proxy is do that really quickly, figure out where the user's going and send it to the correct instance. And so we have a bunch of caching there, so we don't have database lookups in the hot path and things like that. Any other questions about render, game development, life, being remote, living in Boston in the winter? Yes.
If I scale my instances or my web server, I still have to think about scaling my database, right?
Yeah. So the question is, you can scale web servers easily. How do you scale the database? Our answer there is a little bit less mature. Render does have replication. And so the idea there is you have a primary database server, and then you replicate all of the updates to all the other instances of the database. And then you're trading off between, consistency and availability. And so you're taking a little bit less consistency because you might get slightly stale data. So that's one option. Another option we have is called high availability. And what that means is if your primary database goes down, we'll very quickly switch to a replica so that the downtime for your service is minimized. Yeah, I would expect in the next few years, we'll have a lot more options here. We're also sort of constrained by Postgres. Postgres is not traditionally known for great, multi-master sort of setups. This is where Mongo is actually a lot better. But yeah, work in progress. We think what we have now is reasonable for most users. Okay, well, thank you, everybody. If you have more questions, feel free to send me an email, sean@render.com. Thanks for your time.